Hello friends, today we will discuss how to convert general form into symmetrical form of an equation. This equation may be an equation of a straight line or a plane. So let's start. Let us suppose that the equation is this. Can you see this? 6x plus 8y plus 3z minus 13 equal to 0 and x plus 2y plus z minus 3 equal to 0. These are the equations of a straight line. First of all, it is to be known that whenever we are given these kind of equation like two equation of a straight line, then it always means that it's a equation of two planes like this. These are the equation of two planes, and the line which we are talking about is this line, right? This is the line of intersection of these planes, right? Let us continue. Now, what we need to find is the equation in symmetrical form. We know that equation of a line in symmetrical form is of the form x minus x1 by L is equals to y minus y1 by M is equals to z minus z1 by N. Here, L, M or N are direction cosines of that line. But we also know that here instead of L, M, N, we may also write A, B and C. What are these? These are direction ratios of that line, right? So let's start. We need to find out, in order to convert this line in symmetrical form, we need to find out the points x1, y1, z1 and L, ABC or LMN. Direction ratio or direction line of that line, right? This point will lie over this line somewhere over here, okay, and the direction ratios will be A, B and C. So let's start. First of all, we'll find the direction ratios of this line. So let the direction ratios of this line be A, B and C. Okay, the direction ratios of this line be A, B and C. Now, we know that if this line is lying over this line, the line we are going to find out lies both on this plane and as well as this plane. So, the line will be this way, and also we know that the normal to this plane like this will be perpendicular to this line, and the normal to this plane also will be perpendicular to this line, right? And we know that the normal to any plane has its direction ratios same as the coefficients of this x, y and z. So for this plane 1, we will have the normals direction ratios as 6, 8 and 3. And for this plane, we will have the direction ratios of this normal as 1, 2 and 1. So we'll write that. So direction ratios of first plane are 6, 8 and 3 as we said, and direction ratios of second plane are 1, 2 and 1, right? Now we know that this line that we are going to find, its direction ratios are this line is perpendicular to the normals of those planes, right? So we know that if two lines or two planes are normal, then the condition is that A1 A2 plus B1 B2 plus C1 C2 equal to 0. This is the condition. So we will fill out over here and we will write as 6A plus 8B plus 3C equal to 0, right? And A plus 2B plus C equal to 0. Now, by the method of cross multiplication, I am writing in abbreviation form CM, cross multiplication, we can find out A as 8 into 1, 8 minus 3 into 2 is equals to B by 3 into 1 minus 6 into 1 is equals to C by, we will write 6 into 2 minus 8 into 1, right? So this will go as 8 minus 6 equals to B minus 3 minus 6 equal to 6 c minus 6 minus 8, sorry 12 minus 8. So it will be 2 minus 3 and c by 4, right? So direction ratios of the required line are 2 minus 3 and 4. Got it? Now what do we need to find? What else? We need to find the point x1, y1, z1 that lies on the line, right? For this, the most easiest form is that we should put any one of the three variables x, y or z as 0. So we are choosing to put here z equal to 0. Putting z equal to 0 in the equations of the planes, we have 6x plus 8y minus 13 equal to 0, right? And x plus 2y minus 3 equal to 0. Once again, I'll try to show you the original equations of those planes. These were the equations. Here we will put z equal to 0 and then we'll get 6x plus 8y minus 13 equal to 0. And here we'll put z equal to 0 and we'll find out that we're getting the equation as x plus 2y minus 3 equal to 0. Correct, friends? Now we'll continue. Cool. We're getting these equations. Now we'll solve out for x and y values, right? So what we'll do is we'll take this equation as 1 and this is 2. Now for solving, we'll multiply second equation by 6 and we'll subtract it. So 1 minus 6 into 2 implies that 6x plus 8y minus 13 equal to 0, 6x plus 12y minus 18 equal to 0. This will go plus, this will become minus, this will become minus. We'll cancel out these things and then we're left with 4y plus 5 equal to 0, or we get y as 5 by 4, right? Now we'll put x equals to 3 minus 2y, 3 minus 2 into 5 by 4 is equals to 6 minus 5 by 2 is equals to 1 by 2. So we are getting x equals to 1 by 2. So the point on the line is 1 by 2, 5 by 4 and 0, right? So what will be the equation of the line? The required equation will be of the line will be x minus, here we have point as 1 by 2, 5 by 4 and 0, and direction ratios as we have 2 minus 3 and 4, right? So we'll continue. X minus, we're writing the point over here, x minus 1 by 2 by 2 equals to y minus 5 by 4 by minus 3, z minus 0 by 4. 2x minus 1 by 4, 4y minus 5 by minus 4 into 3, 12, and z by 4, right? So also we will see here that here we are seeing that 4 and minus 12 and 4 has common as 4. So we'll cancel out that and we'll find that we are left with the equation as 2x minus 1 by 1 is equals to 4y minus 5 by minus 3 is equals to z by 1. Or the final equation we get is 2x minus 1 is equals to 4y minus 5 by minus 3 is equals to z. This is the final equation. Thank you, friends. We are getting the final equation as this, and I hope that you are able to solve these questions further. That's all for today, and continue to visit our channel regularly. Thank you.